In this video, we will learn about Newton's third law of motion. So you must have experienced when you hit a wall with your fist, you apply some force on the wall, but you also get hurt. This is because the wall also applies some force on you. And this is explained by Newton's third law of motion. So whenever an object A exerts some force on another object B, the object B also exerts some force on object A. And experimentally, it is observed that these two forces are equal in magnitude but opposite in direction. If we call the force exerted by object A on object B as action force, then the force exerted by the object B on object A is called reaction force. To make this concept clear, we are taking up two examples. In the first example, you must have seen that when in sports, one player collides with another player, both players feel hurt because each player applies force to the other player. The force applied by one player on the other is action force. The force exerted by the second player on the first is the reaction force, and both action and reaction forces are acting simultaneously. In the next example, you must have seen when you strike a rubber ball against a hard wall or hard floor, the ball exerts a force on the wall. This is the action force. And in turn, the wall or the floor exerts an equal force on the ball in opposite direction. And due to this force of reaction, the ball rebounds back to you. Now let us see the statement of Newton's third law of motion. Third law states that every action there is an equal and opposite reaction. Now let us understand the Newton's third law of motion better with the help of an example. In this picture, you can see a person is pushing a wall. As he is pushing a wall, he is applying a force on that wall, and that force is what we are calling action force, that is F1. Now in turn, the wall also applies a force on the hands of the person, and that force is reaction force, that is F2. Now as per Newton's third law of motion, both these forces, that is action force and reaction force, are equal and they are in opposite directions. So in other words, we can say that Newton's third law of motion states that when one object exerts a force on another object, the second object instantaneously exerts a force back on the first. And these two forces are always equal in magnitude but opposite in direction. The third point is magnitudes of action and reaction forces are always equal but their directions are mutually opposite. So to understand this point, we have done a small experiment. Let us understand this experiment. We have taken two spring balances. First is spring balance A, the second is spring balance B. The hooks of these spring balances are joined like this. The other free end of the spring balance B is connected to a rigid wall, and a force is being applied to the free end of spring balance A, like this. Now we will observe that the spring balances show the same readings on their respective scales, and it clearly shows that the force exerted by spring balance A on spring balance B, which is the action force, is exactly equal but opposite in direction to the force exerted by the balance B on balance A, which is the reaction force. Fourth point is the action and reaction force always acts on two different objects, and due to this reason, the action and reaction forces can never cancel each other. The next point is, from Newton's third law of motion, it is clear that forces always occurs in pairs, and that is why a single force in nature is not possible. Moving on to the last point, although action and reaction forces are always equal in magnitude, these forces may not produce accelerations of equal magnitude. This is because each force acts on a different object and masses of these objects may be different. So let me explain this point mathematically. We have seen the relation F is equal to ma, and if we rearrange this relation, like we can write this relation as acceleration is equal to force divided by mass. So even if the force is same, the mass may be different, and that is why accelerations can be different. I hope it is clear to you. Thank you.